The first problem reads, Aleph Industries leased a shop for 8 years. To pay for this lease, they had to pay $2,000 at the beginning of every 3 months. For the first 5 years, the interest rate was 4% compounded monthly, and for the next 3 years, the rate was 3% compounded daily. How much did the lease cost in present value terms? Let's understand this problem carefully. We deal here with a due annuity because the payments are happening at the beginning of every 3 months. One important aspect of this problem is that the rate changes. For the first 5 years, which is displayed red here, we see that the rate is 4% compounded monthly. Then the rate becomes 3% compounded daily. This area is displayed green. Because the rate changes, we actually have two annuities here, not one annuity. We have this so-called red annuity and this so-called green annuity. If we were to find present value of the red annuity, it would be located right here at the time of the initiation of the lease. Let's call this present value 1. If we find present value of the green annuity, that present value will be located here. Let's call it present value 2. So present value 2 is located at the end of 5 years. This is the time when the second annuity begins. Both annuities are, of course, due annuities because the payments are happening at the beginning of every 3 months, but also these both annuities are general annuities because in both cases the rate compounding frequency does not coincide with payment frequency. Let's find these two present values and see what we can do next. In the beginning, we need to convert the rate. We'll be finding I2. I2 is found in the following way. It's 1 plus 0.04 divided by 12 because the rate is compounded monthly. The exponent is 12 over 4 because we need to convert this monthly compounded rate to quarterly compounded rate, which is corresponding to the payment frequency, minus 1. I2 is thus equal to 0.010033337. We'll keep this value in the calculator and we'll proceed finding PV1. PV1 is found using the formula for present value of due annuity, which is this. PMT, then comes the fraction, which is multiplied by 1 plus I because that's a due annuity. Present value 1 is thus $2,000 multiplied by the fraction 1 minus 1 plus I2, which we already found here. We'll be using this I2 minus total number of payments. So it's 4 multiplied by 5 years because the first annuity is active for 5 years, dividing by I2 and 1 plus I2. Present value 1 is equal to 36,440.97616. I'm not rounding yet because that's not the answer. We'll still have to do more computation for the final answer. That's present value 1. Now we need to find present value 2, for which I'll be using the green pen. During the green period, the rate is 3% compounded daily, whereas the payments are still every quarter. So this annuity is general. We again will need to convert the rate. I2 is equal to 1 plus 0.03 divided by 365 over 4, because we need quarterly compounded rate, minus 1. This is equal to 0.007527885. Present value 2, this present value is found using the same formula for simple due annuity. Of course, we understand that our annuity has become simple now after we converted the rate. The payment is still $2,000. The I2 we are going to use now is going to be this I2 we found in the second part. Total number of periods is going to be 4 times 3, because here we're dealing with 3 years in the green period. And minus here, of course, is because we're dealing with present value. Divide by 2, and because this annuity is due annuity, we'll multiply by the term 1 plus I2. Present value 2 is equal to $23,037. Then comes 89874. So we'll keep this in the calculator memory, but we keep it with all decimals because, again, we haven't finalized this solution yet. Here is a very important part. We found present value 1. This present value 1 right now, in terms of time, is where it needs to be. It is at time 0. Time 0 is when we initiated the lease. However, present value 2 is 5 years from now. You see, when we calculated present value 2, we didn't input any information about when that annuity started. As a result, this calculation led to present value 2, which is located 5 years from now. Therefore, what we need to do, we need to move present value 2 to present, to the time where present value 1 is, in order for us to be able to add present value 2 to present value 1. Remember, we cannot add amounts which are separated by time because of the time value of money. How do we find present value of present value 2? Look, during that red period, we have 4% compounded monthly as the rate. So now our problem is, we have some amount which is present value 2 5 years from now, and we need to find present value of that amount, keeping in mind that interest rate is 4% compounded monthly. In order to do it, we will be using the formula for the present value, which is the formula for the regular present value, not for annuity present value, because now that amount has become just a regular amount located 5 years from now. That's the formula we're going to use. Let's call this present value 3, because that's the third present value we find for this problem. Future value is present value 2, this amount. 23,037.89874. The rate which is active in that red zone is 4% compounded monthly. That's the rate we're going to use. And because that rate compounds 12 times per year, there are 5 years in that red period, we will be now computing this present value 3. 18,868.11057. What we have done right now, we have moved present value 2 to where present value 1 is. Finally, to find the total lease cost, all we need to do now is to take present value 1 and add present value 3. Let's do it. Present value 1 plus present value 3 is equal to $55,309.09, rounded to 2 decimals. That's going to be the answer for this problem. Now let's use Excel to solve this problem. Let's convert the rate first. We'll use nominal function, which calls for the effective rate. Therefore, inside we'll be using effect function, which will have the input of 4% compounded monthly, and the new nominal rate needs to be compounded quarterly, so we'll put 4 there. Remember, Excel uses effective rate to convert the rate. It cannot convert the rate directly. What we found right now is the nominal rate compounded quarterly, which is equivalent to 4% compounded monthly. Now we are ready to find present value 1, which is the present value of so-called red annuity in this example. The function is PV, of course. The rate is in A1 divided by 4, which gives us periodic rate. Number of periods is 4 times 5, because there are 5 years in that red annuity. Payment is 2000, which we will input with negative sign. Future value is 0. The type of annuity is due, which is 1 in this case. We found that present value of the first annuity is 36,440.98. It's exactly the same answer we got using algebra. Keep in mind that Excel actually will keep all decimals for A2, even though it can display only 2 decimals. Now we're ready to find the present value of the second annuity, which is the green annuity in our example. We'll be finding nominal rate first, for which again we need to find effective rate based on 3% compounded daily. And now this new rate needs to be compounded quarterly. This rate in B1 now is a new rate compounded quarterly, which is equivalent to 3% compounded daily. We will use this to compute present value. Present value is based on the rate, which is B1 divided by 4. Number of periods in this case is 4 times 3, because there are 3 years in that green period. Payment is minus 2000. Future value is 0. And the annuity is due. We obtained 23,037.90 rounded to 2 decimals. However, keep in mind that Excel keeps all necessary decimals. Present value 3 is found as a regular present value, but we use the same function PV. First comes the rate, which is 0.04 divided by 12 for periodic rate. Number of periods in the first period is 12 times 5. Payment is 0 because that's not an annuity calculation. We don't have payment in this calculation. Future value is actually in B2, which will make negative in order to make our present value calculation positive. And because that's not an annuity calculation, it doesn't matter if it's 0 or 1 here. So we'll select 0. If we press enter, we obtain the answer, which is 18,868.11, exactly what we got with algebra. Well, our final calculation will be to take present value 1 and add to it present value 3, which solves this problem. There is also another way to solve the same problem, which is more compact. This another way uses special feature of all annuity functions in Excel. Let's see how this works. I remind that we have computation for the red annuity. In A2, we have nominal rate, which has been converted from the given rate so that the annuity becomes simple. This nominal rate in A2 is for the red period of the annuity. We also have in B2 the nominal rate for the green period, with which the green period annuity is simple annuity. We have used cell B2, this nominal rate, in order to compute the present value for the green annuity, which is present value 2 in this problem. Before, what we had to do, we computed present value 1, which is the present value of the red annuity. Then we found present value of present value 2, which we designated as present value 3, and we added present value 1 and present value 3. Using Excel, we'll actually achieve the final answer with one formula. That's how we'll do it. It's going to be present value. The rate is going to be in A2. We divide it by 4 because A2 contains nominal rate and we need to find periodic rate. Number of periods is 4 times 5 because there are 5 years in that red period and the rate is compounded quarterly in that red period. Payment is going to be 2000. Now this is the trick. The future value is going to be in B3. Usually when we find present value in annuity formulas in Excel, we put 0 instead of future value. But in this case, we actually do have future value which is PV2. We can consider it in the following way. In addition to the regular periodic payments during that red period, we also have the future value, which is located at the end of 5 years. We'll incorporate this future value in this field for Excel function future value. The annuity is due annuity, so we'll put 1 here. The answer is $55,309.09. That's exactly the same answer as we received before, but now in a bit more efficient way, incorporating this future value in this present value annuity calculation. Now we can solve another problem. Starting today, Naim will be paying $1,000 at the beginning of each month. Having made his 36th payment, Naim left the accumulated amount to grow for another 3 years. How much money will Naim have at the end of this investment schedule if the rate is 3% compounded semi-annual? Here is the drawing for this problem. We have a due annuity, which has the last payment at the end of 35th month. There are 36 payments, but the last payment is at the end of 35th month, not at the end of 36th month. That's very important to realize for the solution of this problem. Our strategy for the solution will be this. We'll find future value of this due annuity, which appears to be here. However, our answer needs to be found as of the end of the investment structure, which means our final future value must be at the end of 3 years, starting from the last payment. Because our future value 1 will be 1 period ahead from the last payment. After we find future value 1, we will need to move it into the future. In other words, we'll need to find future value of this future value 1, moving it into the future by another 35 months. Notice, not by another 36 months, but moving it by 35 months, because we will start moving it from the position of plus 36 months, not from the position plus 35 months. Let's see how this will work out. Because this annuity is general, we'll start with the conversion of the rate. We'll take 3% compounded semi-annually and we'll convert it into the rate compounded monthly. 0.002484517. This I2 we found is periodic rate compounded monthly, which is equivalent to 3% compounded semi-annually. With this new periodic rate, we have annuity simple. It is a simple due annuity. We'll need to find future value for this simple due annuity. The payment is $1,000, which will multiply by 1 plus I2, because that's the new periodic rate. Number of payments is 36 minus 1. I2 is in the denominator. And also there is the term because of the due annuity, which is 1 plus I2. Let's compute this future value. $37,703.68071. We keep all decimals because that's not the end of the solution yet. Let's call this future value of the annuity future value 1. We will now need to find future value 2, which is going to be future value of this future value 1. It will be found just like the future value of a regular amount subject to compound interest. The present value in this case is 37,703.68071. And this present value will be now growing at I2. Remember, this I2 is the periodic rate, which is compounded monthly and which is equivalent to 3% compounded semi-annually. It's handy because we have information about growth for 35 months. Remember, it's not 36 months that we have to find future value of future value 1 for, but 35 months. That's why I'll just write here 35 month. You see, if I used 3% compounded semi-annually here, I would have to convert 35 months into the number of semi-annual periods. This would create extra computation, which is unnecessary in this case. I'll just use I2, which is compounded monthly, and I will use 35 month here. This is equal to 41,124.66. That will be the answer for this problem. At the end of this investment structure, Naim will have $41,124.66. Let's see how to solve this with Excel. In Excel, we'll start with conversion of the rate. This is the function nominal, which refers to the function for effective rate. So the nominal rate, which we know is 3%, compounded semi-annually. And we need the rate, which is going to be compounded monthly. Thus, we found nominal rate compounded monthly, which is equivalent to 3% compounded semi-annually. With this rate, we are ready to find future value, which is in this case future value 1. The rate is going to be A1 divided by 12 because we need periodic rate. Number of periods is 36. Payment is 1,000. Present value is 0. And that's going to be due annuity. 37,703.68. Keep in mind, Excel keeps all decimals, even though we see here only 2 decimals displayed. Next is to find future value 2. That is to say, to send future value 1 into the future by 35 months. The rate is going to be A1 divided by 12. Number of periods is 35. Because we have 35 months into the future that we send the future value 1 to. Because this is not an annuity computation, PMT is 0. Present value is in cell A2, but we'll make it negative so that our future value is displayed positive. And the type is not important here because that's not an annuity calculation, so I'll select 0. The answer is 41,124.66. which is exactly the same answer that we obtained using algebra. Let's proceed to the next problem. For the first 3 years, Solomon invested $400 at the end of every month. And for the next 4 years, Solomon contributed $500 at the end of every 6th month. What will be the accumulated amount at the end of 7 years? Assume that the rate is 3.4% compounded monthly. In this problem, we of course need to find the future value, that is amount right here at the end of 7 years, finding which is based on the following process. First, we'll be looking for future value 1. This future value 1 is the future value of the red annuity. This annuity is simple because the payments are every month and the rate is compounded monthly. Remember, the rate is 3.4% compounded monthly everywhere, including this red period. It is a simple annuity, therefore, and it is ordinary annuity because the payments are at the end of every month. Then we'll be looking for future value 2, which is going to be the future value of the green annuity, which starts at the end of 3 years and lasts until the end of 7 years. That green annuity involves payments of $500 at the end of every 6th month, which now makes this green annuity a general annuity. However, it is still an ordinary annuity because the payments are at the end of every month. The final part of the solution will be then in moving future value 1 into the future for 4 more years. Because future value 1 will be located at the end of 3 years, future value 2 will be located at the end of 7 years. In order for us to add future value 1 and future value 2, we first need to adjust future value 1 by moving it into the future. In other words, we'll need to find future value of future value 1. Then we'll be able to add this adjusted future value 1, which we'll call future value 3, and future value 2. We'll show how this works in the solution. In the beginning, we need to find future value 1, which is the future value of simple ordinary annuity. The payment is 400, which is multiplied by the fraction. Periodic rate is 0.034 over 12. Number of payments is 12 times 3, because there are 3 years in that red annuity period, minus 1, and divided by the periodic rate, 0.034 divided by 12. Computing for future value 1 gives us the following result: 15,044.09498. We do not round this value because we are not done yet with our solution. Let's proceed now to finding future value 2. Future value 2 is based on this green annuity, which is a general annuity. We need to convert the rate first. We'll find I2, 1 plus 0.034 over 12, 12 over 2, because we want our new rate to be semi-annually compounded, minus 1. This is equal to 0.017120873. With this rate I2, our annuity has become simple annuity, and we are ready to find its future value. Future value 2 is equal to $500, which is the payment during the green period, 1 plus I2, this I2 which we found here, exponent is 2 times 4, because we have 4 years in that green annuity period, minus 1 over I2. This is equal to 4,248.077771. We do not round this value as well, because we'll still need to use it in future. Next step is to find the future value of future value 1. We'll call this future value 3. It's going to be a regular future value of a regular amount invested for 4 years at 3.4% compounded monthly. Therefore, future value 1 will become present value in this calculation. 15,044.09498, 1 plus 0.034 over 12. 12 times 4 is going to be the exponent. 17,339.39412. At this point, future value 3 is located at the same time as future value 2. Therefore, as our final step, we can add future value 2 and future value 3, which will give us that ultimate future value at the end of 7 years, and that will be the amount Solomon will save at the end of 7 years. Let's find this sum. Future value 2 plus future value 3 is equal to 21,587.47, which will be the answer for this problem. Just to review, in this problem, we do not have one annuity, but we have two annuities. First is the red annuity, and another one is green annuity. After we find the future value of the red annuity, that future value, which is future value 1, is some amount which is located at the end of 3 years. When we find the future value of the green annuity, which is called future value 2 in our problem, that future value is located at the end of 7 years. Because future value 1 and future value 2 are located at different times, in fact 4 years separate those amounts, therefore we need to find future value of future value 1. In other words, we need to find future value 3 to ensure that both of those amounts are at the same time where we want them to be, which is at the end of 7 years. After which we are ready to add future value 2 and future value 3, which we did here. Now let's try to solve the same problem with Excel. In the beginning, we need to find future value 1. The calculation is usual. It's based on the function future value. 0.034 divided by 12 is the periodic rate. Number of periods is 12 times 3. Payment is minus 400. Present value is 0. And this is an ordinary annuity, so it's end of period. Here we go. We have the answer for future value 1. Excel keeps all the necessary decimals here. For our second annuity, which is the green annuity in this example, we need to find the new nominal rate because that annuity is general. It is based on the function nominal, which refers to the function effect. The nominal rate is 0.034 compounded 12 times per year, and we want the new nominal rate to be 2 times compounded per year. With this new nominal rate, the second annuity has become a simple annuity and we are ready to find its future value. You remember how in our algebraic solution we found future value 3, which was the future value of future value 1. Look how using Excel we can actually bypass all that in order to find that ultimate future value, the answer for this problem, in one formula. This is going to be happening in the following way. Future value, the rate is now the new rate, which is P3 over 2, because that rate is semi-annually compounded. Number of periods is 2 times 4, because now the rate is semi-annually compounded and there are 4 years in that green period. Payment is 500. Usually when finding future value of annuity, we'll leave present value as 0. However, in this case, we actually have present value, and that is B1. We'll also make it negative to make sure that the ultimate future value we'll obtain will be positive. So we have payments, $500 at the end of every 6 months, but in addition, we also have that future value 1 amount available to us at the beginning of the growth of the second annuity. And that's how we simplify the process. And that's also the annuity which is ordinary. So we'll enter 0 here. If I press enter, I have the answer 21,587.47, which is exactly the same answer as we found with algebra.